Hey kids, back here on Mr. Murray's Mathland channel, and just to show you a second example of finding critical points for a graph. A quick review. Critical points anywhere where the derivative is 0 or undefined. That's the big idea there. Any x value that is in the domain of the function, of course, where the derivative is 0 or undefined. So finding the critical points for this graph, f of x equals x sine of x plus cosine of x minus sine of x over the intervals 0 to 2 pi. Hopefully you're thinking about the domain of the function and realizing that this domain is all real numbers. Sine, cosine, those are never undefined, unlike some of the other trig functions. So we're going to launch right into finding this derivative. Okay. F prime of x equals, and the first thing I come to in doing this derivative is x sine of x. So you've got to do a product rule there, because that's the product of two variable expressions, that coefficient being a, or being x. So however you like to do it, if you just do it mentally, if you like to do some kind of setup, so a is x, a prime is 1, b is the other function of sine of x, b prime is derivative of sine of x, which is cosine of x. Product of the inners plus the product of the outers, and we get sine of x plus x cosine of x. Just from our product rule there. That gave us that. So moving along, the derivative of cosine of x is negative sine of x. And here at the end, last but not least, the derivative of negative sine of x is negative cosine of x. So we've got this new function here, and this can actually be simplified a little bit. Right here, sine of x minus sine of x kind of works out nicely. Cancels each other out. Nice. Always nice to simplify as you go. And now you have this function, f prime of x equals x cosine of x minus cosine of x. And we're thinking, where is the derivative 0 or undefined? And again, cosine is never undefined, so this is never going to have the f prime being undefined variety of critical point. But I think it's going to have at least one solution where f prime is equal to 0. So we set this equal to 0, and now it's up to us to handle the algebra part of this. I'm going to factor out that common factor of cosine of x. When you factor out cosine of x, you'll have cosine x times x minus 1 equal to 0, and now we set each factor equal to 0. And so we're finding when is cosine 0 and when is x minus 1 0, so that's obviously a pretty easy one to solve. We get x equals 1 right off the bat. And cosine of x being 0 should also be pretty easy for you at this point. You're talking about only in the interval 0 to 2 pi. And cosine is 0 at whenever the x coordinate is 0 on the unit circle. So that would be at pi over 2 and at 3 pi over 2. So there we go. We've got 3 critical points here, all between 0 and 2 pi. So that's it. We're done. But as I like to do often, I really like to establish that connection visually, graphically, between what we're finding with algebra. And so these graphing utilities, these apps are great for that. So let's pull in Desmos here. This is the original function f of x, and I set the window to 0 to 2 pi. And so you can see, the beautiful thing about Desmos, you click on it and it highlights all those things like key points like x-intercepts, y-intercepts, and little critical numbers, actually, relative maxes and mins. So you can see definitely right at 3 pi over 2, there's one, and it happens to be a relative minimum on the graph. And you can see at pi over 2, there's a point, and at 1, there's also a point. It doesn't really look like there's much happening between those 2 points, so I'm just going to zoom in and take a good look at what's going on there. And if you really, really look, you can see that at 1, there is a really muted sort of relative minimum. The graph is going down and it's flat right at 1, but then it goes slightly back up. So that is, if you zoom in enough and change your windows, that'll look like a parabola or any other sort of thing with a relative minimum. And right beside it here, it starts to go up just slightly, but that's all a relative term. And that pi over 2, it hits a relative maximum. It's flat, and then it turns around and starts to go back down. So, kind of a cool thing to see. Two critical points close together. Sometimes they're relative minimums, sometimes they're relative maxes, sometimes they're nothing. Sometimes they're saddle points or other sorts of just, critical, important points to take a look at on the graph. Something's going on. But there we go, 3 critical points. Hopefully you enjoyed getting back in touch with your product rule and unit circle. And as always, if you got any questions, any troubles, reach out and ask. Keep working hard, kids.